Okay students, starting with the ninth unsolved numerical of your textbook, that is in SI units, the differential, all the terms over here are in SI units. The differential equation of an SHM is given by this equation. Find its frequency, that is you need to find n, and find the period, that is t. What you have this differential equation, that is d square x upon dt square is equal to minus 36x. Now what is the differential equation which you all have learned? That is d square x upon dt square is equal to minus omega square x. Compare both the equations. Here the left hand sides are equal, so right hand sides will also be equal. That is 36x is equal to minus omega square x. Here minus and minus gets cancelled, x and x gets cancelled, so omega square, you take it on left hand side, it becomes square root, so omega is nothing but 6, and the unit for omega will be radian per second. So omega is 6 radian per second. You want to find frequency, so omega is equal to 2 pi n. So here is the frequency, so omega upon 2 pi will give you frequency. The value of omega is 6. 2, what is pi? Pi is 3.142 is equal to n. Okay, now 2 ones are 2 threes are, so what remains with us is 3 upon 3.142, that is equal to n. So what will be our next step? Our next step will be applying log, that will be log 3 minus, since the number is in denominator, minus log of 3.142. Now log of 3, since the digit is just 1, so 1 minus 1 is 0, and we don't have 3, we have 30. We'll be looking for log of 30. Let's see the log of 30 in 0. Log of 30 in 0 is 4,771, right? So I'll write that over here, 4,771 minus, again before point we have just one digit, so 1 minus 1 is 0, 0 point. Now 31, 4, 2, 31, fourth one, yeah, this one, and 2, yeah, this one. So it is 4969 plus 3. 4969 plus 3 is 4972. So we'll write that over here, 4972 is equal to n. And as we have applied log, we will also have here antilog. Okay, now we will be subtracting these terms, that is 0.4771 minus 0.4972. Let's subtract. This will become 11, this will become 6. 11 minus 2 is 9. Now again this will become 6 and 16. 16 minus 7 is again a 9. This will become 3. 16 minus 9 will give me 7. Now here 3 minus 4 is not possible. If you borrow something from 0, that will become minus 1. Of course we'll go on that side, left hand side, so that becomes minus 1, and here I have 13. 13 minus 4 is again a 9 point. Minus 1 minus 0 is minus 1. We'll write it as bar 1. So antilog of bar 1.9799 is equal to n. Now antilog, so after point we'll be watching antilog for 9799. See, 97, that is 0.97, 7, 9484. Okay, the number for which we are looking, that is 0.9799. So for 9, yeah, right, for 9 it will be, okay, 9528, and for again for 9 in main difference it will be 20. So 9528 plus 20 will be 9548, right? So we'll write here 9548. As we have minus 1, so it will be 10 raised to minus 1 is equal to n, and just a point after one digit. So it will be, now multiplied by 10 raised to minus 1, it will be 0.9548 is equal to n. Now since this digit is greater than 5, So it will become 9 phi, cancel, and plus 1 over here will give me 5 hertz is the frequency obtained. So next what we want, that is time period. We know the formula for time period. Let's do it over here. Time period is nothing but 2 pi upon omega, right? Yeah, 2 pi upon omega, because omega is 2 pi upon t. So this t and omega comes over here. So 2 into 3.142, the value of pi, and omega is 6, which we have obtained. So 2 ones are 2 threes are 3 ones are 3 point, as 1 is smaller than 3, so 0, that becomes 14, 3 6 are 12, and 2 remains, so it becomes 22. The 3 7s are 21. So let's shop over here. It is 1.067, right? Yeah, sorry, I made a mistake over here. It is 3 4s are 12. Sometimes even I make mistake. It is 3 4s are 12. Okay. Now, since this number is greater than 5, so cancel and plus 1 over here. This will give me 1.0. 4 plus 1, 5 seconds. This is the time period. Here okay. Numerical number 10 of your textbook, Unsolved Numerical. A needle of a sewing machine moves along a path. A needle of a sewing machine. Okay, the sewing machine which you have seen, you might be having at your home, on which your mother stitches clothes. So we are talking about the needle which moves up and down, right? So the amplitude of it means from mean position, maximum displacement from the mean position, that is amplitude. Amplitude is given as 4 centimeter. Okay, now with frequency, a frequency is given to you, that is 5 hertz. This is an SI unit, so you'll have to convert this into SI unit. Let's convert 4 into, when you go from centimeter to meter, you have to just multiply by 10 raised to minus 2, and this is in meters now. Now what else we have? Find its acceleration. You need to find acceleration 1 upon 30 seconds after it has crossed the mean position. Means from here, from the mean position, it has crossed the mean position. Now where after 1 upon 30 seconds, the time given to us is 1 upon 30 seconds. Within this time period, from the mean position, the needle has crossed. The needle has crossed the mean position, and this is the time. At this time period, after crossing the mean position, at this time, what will be the acceleration? Okay, you understood the question? The needle has crossed the mean position. When if it is performing up and down, then it has crossed the mean position, and after crossing the mean position, the time is 1 upon 30 seconds. What will be the acceleration on that time? Wherever it may be, it can be over here or it can be over here, anywhere it can be, but it has crossed the mean position. Okay, it has crossed the mean position. It is not so that it is coming towards the mean position. It is not coming towards the mean position. It has crossed the mean position, and it is going towards either positive extreme or negative extreme. And what is the time? The time after crossing, जैसे उसने मीन पोजीशन क्रॉस किया, ये टाइम पर उसका एक्सेलरेशन क्या है? समझा क्वेश्चन? ओके, लेट्स सी द फॉर्मूला ऑफ एक्सेलरेशन फॉर टाइम at time t, or the time is given to us. What is the formula for acceleration? Textbook page number 113. This is the formula, that is a is equal to minus a omega square sine omega t plus phi. Expression of acceleration at a given time. So here the formula is a is equal to minus a omega square sine omega t plus phi. Now we want the answer in positive, so we'll write here magnitude and here a magnitude. So what happens, this remains in magnitude, and here this magnitude takes away this sign, minus sign. So a omega square sine omega t plus phi. Okay, now for acceleration, when it starts from the mean position, phi is nothing but 0. So the formula gets reduced to a omega square sine omega t. Okay, see, you can see in your textbook, that is page number 113, if the particle starts HSM from the mean position, phi will be either 0 or pi. So let's take this as phi is 0. Now A, I have it as 4 into 10 raised to minus 2, that is nothing but 0.004 or 0.04, yeah, 0.04 meter. So here 0.04 omega square. I don't have omega, so let's find omega. Omega is nothing but 2 pi n. So 2 into 3.142 into n. Do I have n? Yes, I have n, that is 5. So here it becomes easy. 2 5s are 10. 10 into 3.142. This will be nothing but the point shifts towards the right hand side. 31.42 radian per second. Here I have the value of omega. Let's put that 31.42 the whole square and sine omega, again that is 31.42. So 31.42 value of omega into t. Here we get stuck. Here we are stuck. So now what we'll do, here instead of substituting the value of pi, we will not substitute the value of pi, we'll keep pi as it is. Okay, we'll not substitute the value of pi, we'll keep it as it is. So 2 pi n. So 2 pi, and what is n? It is phi. So it is 2 5s are 10. 10 pi radian per second. So now again we'll be coming over here. Let's substitute it again. 0.04, the value of A. Omega will be 10 pi square. Yeah, the equation seems easier. Omega square, that is 10 pi, the whole square. Next is sine omega t, that is 10 pi t. Great. Now after that, 0.04 10 pi the whole square sine 10 pi. What is t? It is nothing but 1 upon 30. So here 0 and 0 gets cancelled. We have pi upon 3. See, this is more easier. Here what you would have done, you would have substituted the value of 30, then you would have divided this. After dividing, you would have got a number, then you will be using sine table. From that you will have to find. So better is this. Now we have sine pi upon 3. We know the value of sine pi upon 3, that is sine 60. See, sine pi upon 3 is root 3 upon 2. So it is 0.04. 10 is nothing but this pi square, and sine pi upon 3 is root 3 upon 2. Okay, now let's write this over here so that it becomes easy for us. Now 0.04 into 10 into 10 into pi square into root 3 upon 2. So I want to write this 0.04 as just 4. Since there are 2 digits after points, so we'll have 100 in the denominator into this 210 into pi square into root 3 is 1.732 upon 2. So this and this gets cancelled. 2 1s are, 2 2s are. After that, let's multiply. 2 2s are 4, 2 3s are 6, 2 7s are 14. Point 2 1s are 2 plus 1, 3.464 into pi square, that is 3.142 the whole square. Now you, after multiplying this, again you'll have to multiply with this. Better you can go with log antilog. Antilog of log of 3.464 multiplication, so plus this 2 will come ahead and log 3.142. I am assuming that the basic use of indices is known to you. So antilog 1 digit, so 0.3464, we'll see the log of that, plus 2, again 1 digit, so point, we'll see the log of 3142. Okay, log of 3464 is, let's check. Yeah, sixth one, and this is fourth one, that is 5391 plus 5, so it will be 5396. Okay, log of 3.142 is 0.4972. You all can check that in your logbook. So anti-log of 0.5396 plus multiply 2 2s are 4, 2 7s are 14, 2 9s are 18 plus 1 19, 2 4s are 8 plus 1 9.20s are 0. Now we will be adding these two digits, that is 0.5396 plus 0.9944. 6 plus 4 is 10, 9 plus 1 10, 10 plus 4 14, 9 plus 1 10, 10 plus 3 13, again 9 plus 1 10, 10 plus 5 is 15.1. So we will be finding anti-log of this digit. So let's find anti-log of 1.5340. So I hope you all know to find the anti-log. See in the anti-log table 53 4, 0 we don't have any mean difference, so 53 4, that digit into, as we have 1 over here, so 10 raised to 1. Let's check what is the digit, what is the number for 5340. It is 3420 and 3.420. Multiply by 10 raised to 1, so it will be 34.2, and since it is acceleration, so it will be meter per second square. So this is the answer, 34.2, and in your textbook the answer given is 34.19, so that is also similar to 34.2 if you cancel 9 and add 1 on the next digit. Okay, let's begin with the numerical number 19, unsolved numerical 19 of your textbook. The displacement of an oscillating particle is given by the equation. The equation for the displacement is given by x is equal to a sin omega t plus b cos omega t, where a, b and omega are constant. Prove that the particle performs linear simple harmonic motion. You have to prove that the particle is performing linear simple harmonic motion. First you need to prove this, and then with amplitude a is equal to, capital A is equal to under square root a square plus b square. So I'll write this amplitude equation over here, and then they say take the square root sign over left hand side. That becomes a square is equal to, capital A square is equal to a square plus b square. This is something similar to Pythagoras theorem, something like Pythagoras theorem, right? One side square plus other side square is equal to hypotenuse square. So I'll draw this, so I'll write this equation in our trigonometric form. So you have seen this, see? When we use trigonometric ratios, we draw the triangle. This is taken as angle theta. This is 90 degree, one side, other side, and this is hypotenuse. Similarly, I draw the triangle over here. This is my one side, which is nothing but A, other side B, as we are going from here towards this side. So I have just drawn the arrows A, B, and my hypotenuse, that is capital A. One side, other side, and my hypotenuse. I can also write A as, A can also be written as square root of A square plus B square. So I hope you understood this, and this is taken as angle theta using our trigonometry. Now, what is sin theta equal to? Sin theta, and what is cos theta equal to? So very easy method to remember, that is Osha Chota. See, Osha Chota. This is for sine and this is for cos. Sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan will be opposite upon adjacent. So sin theta is opposite upon hypotenuse. What is in opposite? B. And what is hypotenuse? Under root of a square plus b square. Let's see for cos theta. It will be adjacent upon hypotenuse. What is in adjacent? A, and hypotenuse a square plus b square. So a upon under root of a square plus b square. Here we have sine theta and cos theta. What we have over here, that is sine omega t and cos omega t. Now I will be writing this equation of displacement which is given to us in the equation or in the question. Sine omega t plus b cos omega t. Now in this expression I don't have this term, so what I'll do, I'll multiply and divide by this term to the whole equation. Multiplying and dividing by this term to the whole equation. Sine omega t plus b cos omega t. What next? Let this be outside and take this one, this denominator, inside. So a sine omega t under root a square plus b square plus b upon under root a square b square cos omega t. Right. Now what is this a upon under root of a square plus b square? It is cos theta. And what is b upon under root of a square b square? That is sine theta. So let's write a square plus b square. A upon under root is cos theta, so it will be cos theta sine omega t plus what is b upon under root? That is sine theta. So sine theta cos omega t. Okay, see, if this is a and this is theta is b, omega t is a and theta is b. Here theta is b, omega t is a. It is something like sine a cos b plus cos a sine b, that is sine a plus b, right? So we'll write that on the next page. Under root a square plus b square, that is sine a plus b. So what is under root a square plus b square? Under root a square plus b square is nothing but capital A given to us. We will write that capital A over here. Capital A sine omega t plus theta. Right? This is my displacement which I have obtained. Let's compare it with the expression of displacement at time t, that is x is equal to a sine omega t plus phi. This is the general expression of displacement at time t. So while comparing, I came to know that this a is amplitude and over this a is also amplitude. And what is this a? This a is nothing but a square plus b square. Hence proved that the particle is, both the expressions are similar to each other. So the particle is performing simple harmonic motion, and since this is amplitude, and when we see in comparison to this equation, this is also amplitude, which is nothing but under root a square plus b square. So this is also proof that the particle is performing simple harmonic motion with this as the amplitude. Okay, so let's start with the numerical number 13, unsolved numerical of your textbook, that is numerical number 13. A simple pendulum, same chapter, oscillation. A simple pendulum performs simple harmonic motion of period 4 seconds. So here we have t, that is 4 seconds. How much time after crossing the mean position will the displacement? Now how much time, that is small t, when, what will be the condition? Displacement, that is x, of the bob be 1/3, means equal to b 1/3 of its amplitude, that is your capital A. This is the condition which is given to you. Okay, now what is said in the question? After crossing the mean position. Okay, after crossing the mean position. So we have the formula for displacement, that is x is equal to a sine omega t plus phi. When you learn the derivation of displacement, in that you all might have seen that when the pendulum starts oscillating from the mean position, at that time phi is taken as 0. See page number 113. If the particle starts ascending from the mean position, at that time your phi is either 0 or pi. So there we'll consider phi as 0. Particles starting SHM from the mean position, since we are considering that a particle has started from the mean position. What they have told over here, they have told it has crossed the mean position, so we'll consider that it has started its oscillation from mean position. So here the value of phi will be taken as 0. So the formula becomes x is equal to a sine just omega t with us. Now a, what is x according to the condition? 1 upon 3a. Then sine, what is omega? Omega is nothing but 2 pi upon capital T and here small t. Then this a gets cancelled. 1 upon 3 is equal to sine 2. What is capital T? That is 4. And here we have t. So 2 1s are 2 2s are. So 1 upon 3 is equal to sine pi by 2, and we also have t with it. What students will do, they'll write this t outside the bracket and they'll write sine pi by 2 as 1. We will not do that because we also have small t with sine. So what will we do? We'll take this sine towards left hand side and that will become sine inverse of 1 by 3. So what remains on right hand side? That is pi by 2 t. Now sine inverse of 1 by 3. What is 1 by 3? Okay, I'll show it to you over here. 3 1s are 1, so 3 zeros are 0, point it becomes 10, 3 3s are 9, 1 is left again, so this goes on. So we'll take after point just 3 digits. So what we have over here, sine inverse of 0.333, that is equal to pi by 2 and t over here. So we'll check for sine inverse 0.333. Okay. Now as we have taken just 3 numbers after point, we will also take one more number, that will be 3. Yeah, of course, if I keep dividing this, we'll also get a 3 over here and 3 3 3. So we'll take 4 digits from the point. So we have 3 3 and again 3 3. So we'll look in the table of sine inverse, that is natural sine. We will try to see 0.33 and the next is 33. Let's say that it has 33 for the convenience, but it is after point we say 3333. We say it as like that. But for better understanding, I'll be counting this as 33. This will be 0.33 and the last 2 digits as 33. Okay. Now let's see over here. All are 0 pointers. From where is this 3 starting? Okay, from here we can start. 0.3. okay, the second digit should also be 3. No. Yes, now it has started. Now we will look for 33. It is 05, it is 22, it is 38. So we'll just stop at this, that is 33 and 22. All are 0 pointers. So 0.33 and 22, that we are obtaining at 19 degree, and this 3322 at 24 minutes. Okay, sure, I'll write this. .33 and 22, where I have obtained this 19 degree and it is 24 minutes. Now I want over here 33 or number close to 33. So we'll look in this mean difference section. That is this for 19 degree. It is, if I add 11 to 22, that is 4 minutes more. If I add 11 over here, I will get the number exact similar to my number. So where did I get that 11? In 19th row. In 19th row I got that 11 for 4 minutes. So I'll add more 4 minutes over here. More 4 minutes over here, and this will get converted into 19 degree and 28 minutes. This 2 upon pi is equal to t. Now it is in 19 degree and 28 minutes. Let's convert this whole into degrees. So what you will do, it's very simple. you will just have to divide it by 60. Once you divide it by 60, see, it will be like this. Okay, 2 3s are 6, 2 1s are 2, 2 4s are 8, 3 1s are 3 4s are 12. You have 2 point, that becomes 20. So 3 6 are 18. Again you have 2 3. It goes on like this. So we have 0 in the denominator. If I take that 0, if I consider that 0, so this digit will become as 0.46 and 6 and 6. We'll consider just 2 digits and we'll add this 0.46 in this 19 degrees. So this becomes 19. Okay, so that becomes 19 and this 0.4666, will just consider 2 digits, that will become 19.46 degree into 2 upon pi, that is your time. As we want time in seconds, so we'll convert this degree into radian. We all know 1 degree is how much? 1 degree is pi upon 180 radians. Okay, so we'll write this 19. We'll write this 19.46. Okay, 19.46 into pi upon 180. Now it is converted into radians and into 2 upon pi. Into 2 upon pi, that is your time. This pi and this pi gets cancelled. 2 1s are 2 7s are 14, 2 8s are 16, 2 9s are 18, 2 zeros are 0. Now we'll do the cancellation with 9 ka table. 9 1s are 9, 2s are 18 point. Now it is 14. 9 1s are 9. We have 5. Then 9 6 are 54, right? So 9 6 are 54. We have 2 with us, that becomes 20 because of point. So again 9 2s are 18. We'll stop over here. So it is, and we have 0 with us in denominator, so that will become 0.216 seconds. That is your time. This is obtained. Okay, hope you understood this. Okay, our next question is question number 14 from your textbook Unsolved Numericals. That is a simple pendulum of length 100 centimeters. So here we have length with us, that is 100 centimeter. We'll convert it into meter. So it will be 100 centimeters is nothing but 1 meter. Find the restoring force. We need capital F. What else? Acting on its bob of mass 50 gram. Let's convert it into kilogram. 50 into 10 raised to minus 3 kilogram. When the displacement, again the displacement is from the mean position, is 3 centimeters. So x is 3 centimeter, converted into meter. 3 into 10 raised to minus 2. Here we have all the terms converted into SI unit. We have the formula for F, that is minus kx. So we don't want that minus. We'll take it in magnitude form. So this becomes F is equal to kx. What I need, that is k. I have the value of x. What is k? K is nothing but m omega square. You all might have studied the theory part. So this is the formula. I have m with me. Do I have omega? No, I don't have omega. So I'll go with omega as 2 pi upon capital T. Now, do I have t with me? No, I don't have t. But I can say that this, whenever the pendulum has length 1 meter, that pendulum becomes seconds pendulum. So we will write there. You can write it. So length is 1 meter. So it is. Seconds pendulum. How it is? It has come. I'll just give a short explanation on that. So whenever you calculate the length of the second pendulum, it is, when you see in textbook page number 123, the formula given is L, length of the second pendulum, LS, G upon pi square. G is what? 9.8. And what is pi? That is 3.142 the whole square. When you multiply this twice, we get it as 9.8 something something. So when you cancel it, it is 1 meter. So it is, of course, length of second pendulum is 1 meter. So from that we can say if the length is 1 meter, it is seconds pendulum. Okay. Okay. This is what I have done. Pi square, pi ka value is 3.142, and then after squaring it I get this as 1.17 something, so I'll just consider it as 9.8, and when you cancel it, it is 1, so it is 1 meter. So length of second pendulum is 1 meter and it is seconds pendulum, so your t will be 2 seconds. So I have t over here, I have m with me. Let's do the calculation. M is 50 into 10 raised to minus 3 into 2 into pi, let pi be as it is, and then it is t, that is 2, so this 2 and this 2 gets cancelled. So what is the value of k now? It is 50 into 10 raised to minus 3 into pi. This is my k. I'll use this values of k over here. K is 50 into 10 raised to minus 3 into pi, and what is x? It is 3 into 10 raised to minus 2. Now let's do the multiplication part. Now this 0, okay, leave. 5 3s are 15, 5 3s are 15, so it becomes 150 into 10 raised to minus 3, 10 raised to minus 2, it is nothing but 10 raised to minus 5. And what is pi? Pi is 3.142. We'll just multiply those digits and we'll obtain the answer. Oh, see, I made a mistake. Oh, it is omega square, so I'll write it omega square. So no problem, don't get confused. See, square of 2, pi ka square, and this t which is taken as 2, uska square. So by hook or crook this is going to get cancelled. What remains over here? That is pi and the pi square. Same things I have copied over here, pi square and 3.142 ka square. I have substituted the value of pi as 3.142, same, and square. It is easy, so no need to get worried or tensed that we have made a mistake. It was a simple mistake which anyone can do. Now we'll just multiply 150 into 10 raised to minus 5 into 3.142 and square of it. Okay, some will choose direct multiplying these digits, and that will be too much time consuming, and some will prefer going by log calculation. So I suggest you by going log calculation. This is 15. Now we have 10, that is 10 raised to 1, and minus 5, that becomes 10 raised to minus 4. So let's write this 10 raised to minus 4 outside. What is now with me? That is 3.142 the whole square. We'll just apply log, so it is anti-log log of 15 plus this 2 log 3.142 and this 10 raised to minus 4, let it be outside. So anti-log, we have two digits, 2 minus 1 is 1 point, and then the digit 2 into 1 digit, so 0 point, and 3142 ka log will look that, and 10 raised to minus 4. So anti-log 1 point. Let's see. I hope you all know to find out the log. It is just easy. 15 के 0 में देखना है, यहाँ पर 31 4 2 में check करना है. Now 1.1761 as it is, we'll multiply with 2. 2 2s are 4, 2 7s are 14, 2 9s are 18 plus 1 19, 2 4s are 8 plus 1 9, 0.20 is a 0 into 10 raised to minus 4. We'll add these digits, 1.1761 plus 0.9944, 4 plus 1 5, 6 plus 4 10, 9 plus 1 10, 17, and then this becomes 11. It is anti-log of 2.1705. Now you will look for 7.1705, that is, I'll show you anti-log of, wait, it is 0.170, and for 5 it is 2, so 1479, adding 2 in that will give me 1481, so it will be 1481. After one digit you'll write point and into 10 raised to 2, as the digit over here is 2. Now multiply 2 in that digit. Okay, we also have here 10 raised to minus 4 and here 10 raised to minus 4. So it is easy, it is 1.481. 2 minus 4 is minus 2. So into 10 raised to minus 2 Newton. Here your force, restoring force is obtained, that is 1.481 into 10 raised to minus 2 Newton. Okay, let me show you some theory first over here. Length for seconds pendulum is directly proportional to acceleration due to gravity. So if there is increase in acceleration due to gravity, there will be increase in the length of the simple pendulum, seconds pendulum. Okay, this you should keep in your mind. Length of the seconds pendulum is directly proportional to your acceleration due to gravity. Just the theory part. Now they both are directly proportional. Find the change in the length of a seconds pendulum if the acceleration due to gravity at place changes from, first it is 9.75 meter per second square, and another place it is 9.8 meter per second square. So for here the length L1, for here the length will be L2, right? Now what I want, find the change in length. If whenever you find the change in length, that will be of course L2 minus L1. Why we are taking it as L2 minus L1? See, here G is 9.8 and here it is 9.7. Here G is more, so of course the length of the second pendulum at this position will be more. So I have taken as L2 minus L1. We need to find this, that is L2 minus L1. Find the change in the length. This will be the change. So let's start. It is seconds pendulum. So the formula, it will be for time period, it is 2 pi L upon G, L1 upon G1. Then it is T2, that will be 2 pi L1 upon G1. Now you should look into this. It is seconds pendulum, so T1 will also be 2 seconds and T2 will also be 2 seconds. Means left hand side and left hand side for both those equations is same. So can I write right hand sides are equal? Yes, of course I can write. So I will write it as 2 pi under root L1 upon G1 is equal to 2 pi L2 and G2, L2 upon G2. This 2 pi gets cancelled, square root and square root gets cancelled. So what we have, L1 upon G1 is equal to L2 upon G2. Now I need L2 minus L1. How will I get that? So can I do L1 upon G1 minus 1, L2 upon G2 minus 1. So what will I get from that? No, a flop idea, because this one will give me L1 minus G1, L2 minus G2. I want L2 minus L1. So this would be a flop idea. What will I do now? Let's take this L2, let this L1 be in the denominator. So see, L2 as it is, I'll bring this L1 in the denominator and I'll take this G2 in the numerator on left hand side. Is it okay? I've just taken this G2 over here and L1 over here. Now if I write G2 upon G1 minus 1, L2 upon L1 minus 1. See, will I get? Yes, of course I will get. G2 minus G1 upon G1 and L2 minus L1 upon L1. Yes, I got this. I'll just take this L1 over here. That is L1 G2 minus G1 upon G1. I'll do this calculation and I'll get my L2 minus L1. So what I think, I'll just write these things over here. It is L2 minus L1. What I need is L2 minus L1. L1. What is L1? See, now you should keep this in your mind. If it is seconds pendulum, length will always be 1 meter. Length will always be 1 meter. So here I am considering my L1, where it is here. I am considering my L1 as 1. G2, I have G2, that is 9.8, minus G1, that is 9.75, upon my G1. G1 is 9.75. Okay, let's subtract this. 9.8 minus 9.75, here 0, 7, 10 minus 5 is 5, and this is 0, and this is 0. So it will be 0.05 upon 9.75. Now let's apply log. So it is anti-log, log of 0.05 minus log of 9.75, anti-log. We have 2 zeros, so 2 bar point 50. We'll look for 50. And it is just 1 digit, so 1 minus 1 is 0, 0.975. Okay, now we'll just subtract this. 2 bar 0.6990, 0.9890. Subtract 0 minus 0, 0, 9 minus 9 is 0, 9 minus 8 is 1. This will become bar 3, and this will become 16. 16 minus 9 gives me 7, and bar 3 minus 0 is just bar 3. So I'll find anti-log of bar 3.7100. Now when we find anti-log, we'll just look for this digit, that is 71 ka 0. When we look for 71 ka 0, we get this as 5129. 5129. After one digit I'll put point, and we have bar 3 over here, so to 10 raised to minus 3 meter. 10 raised to minus 3, so we'll take the digits 3 numbers behind. So for that I'll add some zeros over here so that I can explain it to you. 1 digit, 2 digit, and 3 digit. Here will be my point. So this becomes 0.00512 meter. So this will be the change in length when here. This will be the change in length when the gravity changes. When the gravity changes, at one place it is 9.75, at another place it is 9.8. So this will be the change in the gravity, change in the length, which is just considered as 0 itself, because 0.005, which is, if I cancel this 5 and add plus 1 away, that will be 0.01, a very small digit. So that is just not considered. Hope you understood this. You should always remember length of second pendulum is 2 seconds. 1 meter. Seconds pendulum time period is 2 seconds. Okay, and length is 1 meter. Okay, what is asked in the question? Find the number of oscillations performed per minute. Okay, so we want oscillations performed per minute. What is that? Oscillations performed per minute is nothing but my frequency. Okay, it is nothing but my frequency. So I want my frequency. After that, frequency is n is equal to 1 upon t. This is the formula. Number of oscillations per minute. Oscillations performed per minute. Number of oscillations. Okay, what is asked now? Per minute by a magnet which is vibrating in a plane of a uniform field. The magnetic field is uniform, of the field is given, that is 1.6 into 10 raised to minus 5 Weber per meter square. The magnet has moment of inertia. We have I, that is 3 into 10 raised to minus 6 kilogram per meter square, and magnetic moment, that is mu, as 3 m per meter square. All the units are in SI system. Now we have the formula for okay, we need frequency. What is frequency? That is n is equal to 1 upon, what is t? Okay, t is equal to 2 pi upon omega, right? So I'll write over here, that is 2 pi upon omega. This goes in the numerator and n becomes omega upon 2 pi. So I just want omega. Your textbook page number 126 gives me the time period, that is 2 pi under root 1 upon mu b. From this I can get my omega, right? What is omega? Omega is this term. I'll just write this. T is equal to 2 pi under root I upon mu b. T is equal to 2 pi under root I upon mu b. Okay, now if I write this term as, if I take this term in the denominator, so it will just flip. It will become under root mu b upon I. Just compare this with this equation. What is omega now? Omega is mu b under root mu b upon I. So I'll write here, omega is under root mu, that is magnetic dipole moment, b upon I. We have the value of all the quantities. Mu is 3. What is b? It is 1.6 into 10 raised to minus 5. And what is I? It is 3 into 10 raised to minus 6. This 3 and this 3 gets cancelled. So what remains with me? If I cancel this 10 raised to minus 6 and 10 raised to minus 5, what remains? 10 raised to minus 1 remains in the denominator. So I'll take this 10 raised to minus 1 in the numerator. So it is 1.6 into 10 raised to 1. That becomes 16. Square root of 16 is 4. So I got this omega in radians per second. I'll use this omega over here. In this equation I'll use my omega. Okay, so n is equal to omega upon 2 pi. So omega upon 2 pi, what is omega which I obtained? That is 4 radian per second and 2 pi. Now what is asked in the question? I want it in minute. So I'll convert it into minute. 4 radians and your 2 pi. It is easy. 1 minute is equal to 60 seconds. If I have 1 second, it will be 1 upon 60 minute, right? What I have over here, just 1 second. So at this 1 second, I'll write 1 upon 60. 1 upon 60 and minute. See, it is obtained in minute now. So what is our next step? 4 upon 2 pi and 1 upon 60. So 1 remains over here and 60 goes in the numerator. Now I'll have to just do the cancellation part. 2 1s are and 2 2s are, 2 6 are 12. So that becomes 120 upon 3.142. Okay, if I am taking the value of pi as 3.142, means pi is in radians. If I am taking the value of pi as 180, means pi is in degree. Here I have taken the value of pi as 3.142, means my pi is also in radians. So what happens? This radian and this radian gets cancelled. So what remains with me is just my minute. Okay, now 120 upon 340, and I'll take this minute. Am I right till here? I hope I am clear to you. Now As I have cancelled the radians over here, so I have not written pi as radian over here because I have just substituted the value of pi over here. So now I'll apply log. So anti-log of 120 minus log of 3.142 per minute. Anti-log, we have 3 digits, so 3 minus 1 is 2, minus just 1, so 0 point per minute. Let's see the log. We'll subtract these 2 digits, that is 2.0792 minus 0.4972. 2 minus 2 is 2, 9 minus 7 gives me 2. Okay, this becomes 1, this becomes 10, then 9, 17 minus 9 gives me 8, 9 minus 4 gives me 5, and here I have 5. So 1.5820. So anti-log of 5820. It is 3819 after digit 1 digit point, and since here we have 1, so 10 is to 1, so that will become 38. We have cost per minute 38.19 per minute oscillations per minute. So here is my frequency, that is 38.19 oscillations per minute. Okay, hope you understood this. This was the question given to you, that is find the number of oscillations performed per minute. So these are the number of